Welcome to video 3.2.2. We're going to look specifically at precipitation reactions with an example. So we can predict whether a precipitate will form by comparing QSP to KSP. Now let's define what these are. So QSP is the current state of the solution. So this is the current state of the ions, how many ions are currently in our solution. So current state of solution. And KSP, that's the maximum amount that can be dissolved. Max solute in solution. Okay, so we can figure out what we're currently at in our solution, or what we're going to add, and then we can compare it with what the maximum the solution can hold is, and we can see whether there's too much in there. If there's too much, so that means if the QSP is greater than the KSP here, so if there's too many ions in solutions, we're going to form a precipitate, just because the solution can't hold that much solution. However, if the QSP is less than KSP, that means if you have less in the solution than the solution can hold, the reaction is going to shift right, and you're going to shift toward ions, and you're not going to form a precipitate. Okay, so let's take a look at what's happening here. Example 4, a 500 ml solution of calcium chloride. Okay, calcium chloride with a chloride concentration of 8.0 times 10 to the negative 6 molar is added to 300 ml of a 0.0040 molar solution of silver nitrate. So silver nitrate, AgNO3. Will a precipitate form when equilibrium is reached? The KSP of silver chloride is 1.6 times 10 to the negative 10. First, let's see, they're giving us the KSP of silver chloride. So I know that this is likely, this is a clue from the problem, that this is going to be what I care about. This is my insoluble salt. So let's just go ahead and write our reaction here for what's happening. So we have our calcium chloride, CaCl2, and that's going to be aqueous because it's a solution, plus silver nitrate, AgNO3, also aqueous. It's going to be in equilibrium with its products. This looks like it's going to be a double replacement reaction, so calcium and silver are going to switch places. So we're going to get our calcium nitrate, CaNO3, and nitrate's -1. Calcium's +2, so we need 2 nitrates. That is soluble, you know from your solubility rules, plus silver chloride. And then our silver was +1 because nitrate is -1. So we have +1 here, and your chloride is -1, so just AgCl. Now this is your solid. This is what you care about. Just making sure this is balanced here. There's your balanced reaction. So this silver chloride, this is the thing that I care about right here. That's going to be the solid that's going to form, and I'm trying to figure out if I'm going to get a precipitate of this, or if there's so little of it in solution that it will just stay dissolved. Okay, so first thing, my total volume of solution, I need to find here. Well, let's see, I had 5 milliliters of calcium chloride, 300 mils of silver nitrate. So total volume of solution is 500 plus 300, that's 800 milliliters. Now I need to figure out my QSP. I need to figure out how much how much chloride is in my solution right now from the calcium chloride, and it tells me that, and how much silver is in my solution from my silver nitrate. Well, that tells me the molarity per 500 mils. This tells me the molarity per 300 mils, but I need the molarity for the whole total solution. So to figure that out, my chloride ion concentration is equal to my 8.0 times 10 to the negative 6 molar. So that's the concentration of the chloride ion, but that's only in 500 mils of solution. So that's per 500 milliliters. So these guys are going to cancel out. Milliliters is going to cancel your liters as long as you change units. And basically on the top you're going to have moles. Now we want the overall concentration, so to get back to moles per liter, we are going to divide this by the entire volume, the whole solution. So divided by 800 milliliters. So here your mils actually cancel out, and you have the molarity of your chloride ions in the total solution now, and not just in the 500 milliliters. So plugging that in, you get 5.0 times 10 to the negative 6 molar of chloride. Now looking at silver, you guys go ahead and pause the video and you figure out the molarity of silver in the overall solution. Okay, so you should start with the volume or the molarity in the volume you have, and you're just smaller amounts that you're going to add. So 0.0040 molar, and there was 300 mils of that to start, divided by your overall volume, 800 mils, and that's going to equal 0.0015 molar of silver. Okay, so these are the molar volumes in the total solution. Now let's look at silver chloride in itself. So silver chloride, what we care about, is the dissociation of silver chloride. So AgCl in solution is going to dissociate into Ag plus Cl minus, right? So we have our silver ions and our chloride ions. And those are going to be in equilibrium with the silver chloride solid salt here. So this is our solid salt. And these guys are aqueous. To get Q, we do Q the exact same way that we do K to compare our ratios. So we take our Q, set that equal to the concentration of silver times the concentration of chloride, and we don't count AgCl. That's our reactant. We don't care about it. All we care about is our product, the ions that are going to be able to be formed in solution. So let's see what our Q is. So the concentration of silver is 0.0015 molar. 0.0015. This should be a parentheses. And our chloride, which is 5.0 times 10 to the negative 6. 5.0 times 10 to the negative 6 molar. And these aren't squared or anything like that because you just have a 1-to-1 ratio here. Plugging these into your calculator, multiplying them out, you get Q is equal to 7.5 times 10 to the negative 9. You're like, okay, great, we got Q. Now what do we do with it? Well, we have this Q, and now we can compare it to our KSP. Now it says in our problem originally, the KSP of silver chloride is 1.6 times 10 to the negative 10. So our K equals 1.6 times 10 to the negative 10. So which one is bigger? This Q is going to be bigger. So the Q is bigger. Q is bigger than K. And so that means that the current state is that there are too many ions. There are more ions in the solution than the solution can hold, because the solution can only hold this much, 1.6 times 10 to the negative 10. But I have 7.5 times 10 to the negative 9, which is a bigger number. So that means the leftovers are going to precipitate out. So you're going to see a precipitate. And then just up here, as our rules, remember, you can see that here, if Q is bigger than K, the reaction shifts to the left and will form a precipitate. That means this reaction is going to shift to the left, and all these ions, well, there's too many ions, so the leftover ions are going to shift left and form solid silver chloride, and you're going to see a precipitate in solution. So Q is bigger than A, so a precipitate, this is an abbreviation for precipitate, forms. So Q is bigger than K, so a precipitate forms. And that would be a valid justification for your answer as well. Okay, that was the end of the precipitation notes, and that's the end of video 3.2.2.